Hey everyone, let's do the Unit 6 Lesson 3 practice, or 7.6.03 as I think they call it on Desmos. This is really important stuff, you guys, and arguably I would say some of this stuff is the stuff you need the most going forward in math and 8th and 9th grade and all that stuff. So let's make sure we do it right. Let's see here. The first part here just says determine the value of each expression. So the value of an expression is the answer you get after you do all the math. And each of these are expressions because they don't have like an equal sign and stuff on the other side of the equal sign. That would make them equations. All right, so in other words, we have to evaluate these, right? To get a value is to evaluate. All right, so I can grab a calculator. I mean, you could do that too. Oh, do they have one here? Complete this screen without the calculator is what they want you to do. All right, well, let's do it. Where's my Zoom drawing tools? I'm clicking the thing here. Well, let me do it. Oh, there we go. What color? Can we get like a dark green? Yeah, let's do that. All right, so here we got negative 0.09 times 100. Notice I wrote it the other way. They've got it 100 times negative 0.09. Commutative property. I'm allowed to do that if I want. So multiplying a number by 100 just moves its decimal point 2 spaces. That's what's cool about multiplying by 10, 100, 1,000, etc. So this decimal point is just going to go whoop, whoop. And so our answer is going to be 9 because it's like right there behind the 9. But it's going to be negative 9, right? Because we have a negative number times a positive number. All right, next, let's see here. We got negative 7 times negative 1.1, I mean to say. So let's see here. Let's set it up like this. Let's do 1.1 times 7. I'm not even going to worry about the negative signs because I know my rules. A negative number times a negative number has to come out positive. So whatever I get, positive for sure. 7 times 1 is 7. Bring my decimal point straight down. 7 times 1 is 7. We're going 7.7 here. All right, next we got negative 7.3 times 5. So this time I've got a negative number times a positive number. So I'm confident that the answer turns out negative no matter what. So I could do the math without even thinking about negative signs. I'm just going to do 7.3 times 5 over here. And whatever I get, I know my answer should be negative. So 5 times 3 is 15. So let me put this 5 here. Let me carry that 1 over there. Let me bring my decimal point straight down. 5 times 7 is 35, plus that extra 1. Looks like we got 36.5, but we're entering negative 36.5. And last but not least, we have negative 0.2 times negative 0.3. So I know a negative times a negative is a positive, and 2 times 3 is 6. So it's going to be 0.6. All right. Wait, no. I think I almost oofed that up. If it was 0.2 times 3, or if it was 0.3 times 2, then it would be 0.6. I almost messed that up, though. So here's a little trick, a way to think about it. When you multiply decimals like this, so let's say we're doing 0.2 times 0.3. So 3 times 2 is 6. Then 3 times 0 is obviously 0. And then this 0 times, it's just a bunch of zeros, right? What you do is you count the total number of decimals, numbers behind the decimal point in your problem. So you got 1, 2. So that means that when you finish, you should have 2 numbers after the decimal point. Another way to think about it is 0.2 is the same as 2/10, and 0.3 is the same as 3/10. And when you multiply these as fractions, you get 6 1/100ths. So my 6 should wind up in the 100th spot. Can't believe I almost messed that up and gave it 0.6 or 6/10. See? You know, when it comes to math, no matter how long you've been doing this stuff and now however many college classes you've taken or whatever, we're still all human. We still all make mistakes from time to time. Oops, now I got 2 decimal points. Geez, I gotta get it together. All right, let's move on. All right, so we're given a tape diagram and it asks us to select the story that matches the diagram. So let's look at the stories. A family buys 6 tickets to a show, okay? They also pay a $3 fee. They spend $27 total. Okay, so I see the $27 total on top of this diagram. So that part matches. Let's read the other one. Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends and then has 6 ounces for himself. Okay, so in this second story, the 6 is the known value, right? We know for sure he poured 6 ounces for himself. And so that should match with a number in the tape diagram. We should see that number 6 in there, and we do. Then the unknown amount is how much he pours for each of his friends. Okay, so that's not in the tape diagram, right? But what we do see is we see 3 unknowns representing the 3 friends, right? One friend, 2 friend, 3 friends. Compare that to the other story. This story says a family buys 6 tickets to a show, but doesn't tell you how much the tickets cost. And so this tape diagram would need to have an X or some other letter 6 times in it, right? For these 6 tickets. So they're trying to confuse you with the 6 and 3 here. I think we should go with this one, though. I think the 3 X's represent the amount that each friend is getting of juice, and then the 6 is the 6 ounces he poured for himself. Select the equation represented by the diagram. All right, so let's look at it this way. You can take a tape diagram and turn it into an equation pretty easily by just going x plus x. I'm just adding up the pieces, adding up the boxes or whatever. Plus x plus 6 equals the number across the top, 27. Ooh, almost kind of ran out of space there. And then we use combining like terms, right? This is 1x, this is 1x, this is 1x. When you combine those up, you get 3x. I've still got plus 6, and I've got equals 27. What does the x represent in this case? So it's our unknown, right? What they're asking us to do here is define the variable. Anytime you're using a variable in some math, or especially where you've got like a word problem, you need to understand and be able to say and show it on your paper somewhere. What does that variable represent? Not just the number it equals, like when you get the solution, but like what quantity from the problem is it supposed to like hold a place for? And in this case, x is the amount of juice Diego poured for each of his friends. All right, so let's submit that. And I think we got it. Okay, so we're still kind of in the same question about Diego and the juice, right? Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends. That's these 3 boxes with X's in them. And then he has 6 ounces for himself. So the equation is 3x plus 6 equals 27. We're going to determine the value of x. All right, so let's kind of use the tape diagram to figure out like a visual way of solving this question. Let's look at a typical solution strategy, and let's look at the way to do it algebraically. So I'm going to show you like 3 ways to solve this thing right now. I'm trying to move some stuff out of my way here so that I can see my own screen better. All right, so I'm going to start with the tape diagram. So we know that he poured 6 out of the 27 ounces for himself, right? So if we were to like kind of cut out or like scribble off this part of the tape diagram, we've just made the tape diagram like 6 shorter than it was. So we had to take 6 away from this 27 here. So 27 minus 6 equals 21. So now the top, so like imagine the top of this diagram now says 21 instead of 27. And the only part that we have to care about now is these 3 boxes, each with X. Well, we're going to take this 21 and we're going to split it into 3 equal boxes here, right? So like imagine you've got 21 of something, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And we want to split these things equally into the 3 boxes here. Well, we could take these 7 here, and that counts for that X. These 7 here, and those could go in that box with X, and these 7 here will be that X. So it looks to me like X is going to equal 7. Okay, another way people might solve this question is sort of the same as we just did here, but more like mathematically using calculations. They might go, okay, he originally had 27 ounces of juice, but he poured 6 for himself. So that's 27 minus 6 equals 21. And then I know that 21 got split between the other 3 people that were there, his friends. So let me do 21 divided by 3, and I get 7. Boom, there's my answer. If you understand either of those 2 ways to do this question, then you can also understand the algebraic way that I'm about to show. It's just a different way of writing it that's kind of like the way everyone does it, where this is what we're trying to learn how to do. So I start with my equation that represents the whole thing. 3x plus 6 equals 27. And my goal is to get x all by itself. So it says x equals blank, which is the answer. We call it the solution. And the way I do it is by looking at what operations are happening to x. So I see 3 times x here. This is times when you have the number right next to the letter. And this is addition, right? Plus sign, addition. Okay, I do the opposite of the operations I see. I see addition, so I'm going to use some subtraction. And I see multiplication, so I'm going to use some division. Just like we did in the previous strategy. I'm going to do the same things. Look up here. The first thing we did was minus 6. I want a minus 6 as well, because I want to get rid of this plus 6. But if I do it to one side of the equation, I must do it to the other side. That's the way equations work. That's how we keep them balanced and equal. Well, what happens on this side is I get 3x plus 6 minus 6. But a plus 6 and a negative 6, minus 6, whatever you want to call it, doesn't matter. That equals 0. So I get 3x plus 0 equals 21. All right, now I want to divide this 3 away from the x because it's multiplying the x. I don't want it there. I'm going to divide it. So I'm going to divide by 3. The same thing we did up here. Well, if I do it to one side of the equation, I got to do it to the other side. And so now this 3 and this 3, they divide with each other and they make a 1. So I get 1x, or just x, equals 7. The same answer we got. All right, so the answer to this one's going to be 7. What does the solution tell you about this story? So anytime you get answered or asked a question in words, it's always good practice to answer it in words because it shows you understand what your solution means, right? We got 7. 7 is the answer. 7 is the solution. What does it mean? It means Diego poured 7 ounces of this magical, delicious juice for his friends. I should say for each of his friends. For his friends sounds like it's like a total of 7. So for each of his friends. All right, let's move on. So I think we're essentially going to do the same thing all over again. It's just a different one. Oh, so look, I think it's the same 2 options we had before, but this time the other one's the correct one. See, this time when I look at the family buying the tickets thing, it says a family buys 6 tickets to a show, but they don't tell us how much the tickets cost. So that's going to be our unknown that we're going to represent with that with a letter. And look, I've got 6 of them. 1, 2, 3, 4, 5, 6. they also pay a $3 parking fee. So that's a known thing, right? We know exactly how much that parking fee was. It was $3. So we should see 3 in the tape diagram, which we do. And they spend a total of $27. So that 27 is on top. All right, so I think that's pretty clear. I think we got to go with this one. So we select the equation that matches it. All right, so I'm going to go through this a little faster than I did last time because you've seen this once before. I have 6 x's in this tape diagram. We write that as just 6x. And then I've got plus 3 there at the end, 27 on the top, so equals 27. Boom, 6x plus 3 equals 27. So they're just switching the 6 and the 3 on us here, because last time it was 3x plus 6. Oh, what just happened? Did I just glitch out? Yo, Desmos, what's going on? Okay, and then what does x represent in this situation? So we need to define the variable. X represents the, so let's look back up at the problem. It said 6, the family bought 6 tickets to the show. That's the thing we don't know, is how much did those tickets cost? The cost of each ticket to the show. Boom, variable has been defined. And we can move on. So they're gonna ask us to solve it again, right? I'll show you all 3 ways again, but I'm gonna do it way faster than I did last time. So we've got the tape diagram first. I wanna take this 3 off the tape diagram because I don't need it. I'm trying to figure out what x equals. So let me take 27 minus 3 equals 24. So the top of this tape diagram now says 24. I've got 6 boxes to spread that 24 into. So let's imagine I had 24 things, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, and so it's gonna look a little weird, but I'm gonna take these 4 right here. Boom, they can be that x. And I'm gonna take, let's see here, these 4 here, and that's that x. These 4 here, boom. All right, these 4 things over here, and here, and these 4 right here, to that x. So each x gets 4 in its little box, so I'm pretty sure the answer is gonna be 4. Let's do a different strategy, arithmetically, using arithmetic. So we know they paid $27 total. Let's take off that parking fee. We're gonna get 24. Then we know with that $24, they bought 6 tickets, so let's divide that by 6, and we get 4. So the answer looks like it's gonna be 4. Let's do it algebraically now. So we start with the equation, 6x plus 3 equals 27. My goal is to get x by itself. So I see multiplication and addition in this equation. I'm going to use the opposites, subtraction and division, to solve. I'm going to subtract this 3 over here to get rid of it, but I got to do the same to the other side. So I get 6x equals 24. Notice I didn't even bother writing anything with this plus 3 and this minus 3 because I know they clash together, they make a 0, they're gone. That's my whole goal. That's how this process works, is making things go away. All right, and so now I've got 6 times x equals 24. Let me divide by 6 to get rid of that times bit, times 6. And I get x equals 4. All right, so let's enter that in. And what does the solution tell you about this story? So we figured out that each ticket costs $4, right? So that's what we put here. Each ticket cost $4. Boom. All right, we got it. Let's keep going. So match each tape diagram to an equation. Okay, looks like 1 card will be left over. All right, so these 2 equations are super similar, right? One is 5 times x plus 1. So this should have 5 boxes with x's in it, and then 1 box with an x. Boom. All right, this other one, it says it has a 5 outside the parentheses, right? And what that means is 5 times all the stuff in the parentheses. I like to call it the quantity. So I would read this as 5 times the quantity x plus 1. Saying the quantity out loud sort of tells someone who's listening to you that the next things you say are like connected in parentheses. Okay, well, what that means is I should have 5 groups of this quantity x plus 1. That looks like it's going to be this card over here, right? This one would be like, I've got a 5 separately, right, in its own box, then plus 1 singular x, and then plus a 1. So this would be 5 plus x plus 1 equals 20. That doesn't go with either of those equations. All right, so here, this is some practice rate stuff, some review. You're trying to find unit rates. And the way you should think about it is they want you to find how far, the number of miles each car can travel in 1 hour. That's AKA also known as miles per hour. That's what you're measuring when you look at like the speedometer in a car. How far can you go in 1 hour? Miles per hour. And if you're in Mr. Thomas's class, you know that the word per almost always means to do divided by, especially when you're trying to find a rate. It guaranteed means you're doing divided by when you're trying to find a rate, which is what miles per hour is, right? It's a rate of speed. So literally just take the miles and divide by the hours for each of these. But Mr. Thomas, some of them are decimals or fractions. You can do it, right? So maybe you forgot this little thing. I'm going to do one of them for you, and then you can kind of figure out the rest. I'll do what I think looks like the hardest one. 7.5 divided by 1/4, right? That's what you need to do to get this answer. 7.5 divided by 1/4. I like dividing fractions. It sounds scary, but when you do it, it's actually kind of easy as long as you remember the trick. So first, let me write 7.5 as a decimal. Well, 7.5, that's the same thing as 7.5 over 1, right? We're allowed to put any number over 1. It doesn't change it. Okay, well, I want this decimal point to move over 1 space, though. I don't want a decimal in my fraction, so I'm going to write it as 75, but then I have to move this decimal also, so 75 tenths. So what I'm really trying to do is 75 tenths divided by 1/4. And I'm going to do a keep, change, flip. Keep, change, flip is just a trick for doing fraction division. What this question is really asking, this question right here, is how many times can the number 1/4 fit into 75 tenths? It's kind of a weird question, right? But we know 1/4 goes into 1 4 times, and 75 tenths is about 7. So it should be about 28, 29, 30 times, somewhere around there. But it's hard to think of it that way, right? How many 1/4 can I fit into 75 tenths? Luckily, there's this trick. Keep, change, flip. Keep, change, flip. Trick. Keep, change, flip. And really, it almost borderline doesn't make a ton of sense why it works. I mean, I could explain why it works, but it'd take too long. What matters is that it works. So we keep the first fraction, right? I'm keeping it, meaning I'm not doing anything with it. It's staying the same. I kept the first fraction. Next, I'm going to change from division to multiplication. I'm just going to change. I'm going to go to multiplication instead now, because multiplication is easier than division. But in order to do that, in order to change from division to multiplication, you have to flip the next fraction. That's how it works. That's what allows you to go from multiplication to division. You flip. So instead of 1/4, I'm going to multiply by 4, which makes sense because 1/4 can go into a number, can go into 1 4 times. So whatever number you're trying to fit 1/4 into, it should just be 4 times that number because you're fitting 1/4 into it, right? Four of those in every one whole number. So 75 times 4, 300, right? I think. 10 times 1, 10. 300 divided by 10, 30. I called it. It was 30. All right, so that's all it is. Just take the miles divided by the hours. I'm not going to do all of them for you. And then the last one. We assigned one of these as extra credit before. This is called a system of equations. So this is a system of 1, 2, 3, 4, 5 equations with 5 variables. It's more of an eighth grade skill to be able to do these. So it's extra credit in my class. You do not have to do this slide in order to get a 4. I'm pretty sure Mr. Wong's telling his class the same thing. But if you just want to check your answers, here, I'll pull up the teacher answers for you real quick. Maybe that's the only reason you turned on this video. All right, that's what you're supposed to get. If you got that, good job. You've got big brain. All right, I'll see you.